Well, now we're doing the review for 6.2, and we've got to find the exact value of the tangent of the inverse sine of negative 1/2. Well, the inverse function is an angle, and this angle, since it's inverse sine, is either in the first or fourth quadrant. And since it's negative, it's in the fourth quadrant. And the reference angle is pi over 6, because sine of pi over 6 is 1/2. And since it's in the fourth quadrant, it's going to be negative pi over 6. So we're talking about, that is, the inverse sine of negative 1/2 is negative pi over 6. Now we're finding the inverse tan, then, of negative pi over 6. And that's going to be negative 1 over root 3. And now let's rationalize that denominator by multiplying by 1 in the form of root 3 over root 3. And now we get negative 1 times root 3 is root 3. And in the denominator, root 3 times root 3 is 3. And we've got that one done. Now let's do number 2, and we've got to find the exact value of the sine of the inverse tangent of negative 1. And so the inverse tangent of anything that's an angle, and the range of the inverse tangent function is the first and fourth quadrants also. Since it's negative, we're going to be in the fourth quadrant. The reference angle is pi over 4, because tangent of pi over 4 equals 1. So now we're going to, in this case, since it's negative, it's going to be the angle is going to be negative pi over 4. And so this equals negative and 1 over root 2, and we'll rationalize that denominator by multiplying by 1 in the form of root 2 over root 2, and it's going to be negative, and root 2 times root 2 is 2, and 1 times root 2 is root 2. And we've got that one done. Now let's do number 3. And we've got to write the tangent of the inverse sine of u as an algebraic expression. This is a trigonometric expression. We've got to write it as an algebraic expression. So we can do that. We'll just draw a circle, and we'll so we've got the inverse sine of u, and that's a ratio. We're evaluating a ratio, and we'll call this angle theta. And so the ratio, in the numerator we have u, so that's the length of the side opposite. In the denominator we have the radius, which happens to be 1. We don't see it because the 1's understood. So therefore, using the Pythagorean theorem, for the length of the side adjacent to the angle, we get 1 minus u squared. And by the way, let's go over that quickly. If you, for example, I'll call this x. So if you square x and you square u and you add them up, you get 1 by the Pythagorean theorem, so x squared equals 1 minus u squared, so x equals, it's only going to be the positive form, 1 square root of 1 minus u squared. So that's where that came from. And now let's deal with this. So as an algebraic expression, we're going to get the tangent, so I'm going to write this again, tangent of inverse sine of u equals the tangent of theta, which equals the length of the side opposite u over the length of the side adjacent, square root of 1 minus u squared. And now we've written this expression in terms of an algebraic expression in terms of u, and we're done.